Hey CIS 102, in this video I want to add some perspective to the topics that the text covered. I specifically want to talk about software development, focusing on license and programming methodology. One of the things that the text talks about is software licensing, which is applicable if you are going to create a solution or product that's going to be distributed. But this isn't the only type of software licensing that comes into play when developing software. If while you're in the process of creating software, you find some type of a library on the internet that is open source, you can download that and try to include that into your solution to try to streamline your development process. Maybe it's going to save you some time and you're going to get your product out faster by doing this. But when you do that, you need to be cognizant of the fact that you need to understand the software licensing that is related to that particular open source solution that you're including. One of the things with open source is that that library that you're including may also consist of other libraries that have been used to create that particular library, and you have to then go through and take a look at the licensing of all of those other libraries as well as the one that you're including into the actual solution. So it can get a little bit of a hot mess when you're trying to determine if this is something that you can add to your solution or not. In some cases, the software licensing requirements may not be something that you want to go forward with, and you may then determine that you're going to create your own solution to fill that gap. In other means, the licensing requirements might be okay. You're willing to accept those terms, and you would just have to then go through and fulfill the obligations of the software licensing agreement in order to utilize that in your product. But it can be very, very messy and very time consuming and very confusing. And sometimes it actually means that you have to ask somebody like a legal consult to actually come into play to determine whether you can legally use some of the libraries in your product. My development experience has always been working for a corporation in the IT department, so licensing a product for distribution has never really come into play. However, licensing related to including an external library or utilizing some type of icons or images from the web have come into play. To give you a really simple example, if I was tasked to create some type of a new internet website for my company that I was working for, right now I'm not really working for any company, but if I still was, I might decide that I want to incorporate and use some Google materialized icons in my website. If I'm looking at the icons, they have a nice collection of icons here. It certainly would save me time having to try to find somebody that would create me some original icons. I could go ahead and look for any licensing, and right now they show us a very nice location, what the Apache license is. I can click on it. I can read through all of the licensing agreements and all of the terms of that license, and then I can make a determination whether this is something that I would want to utilize and follow the licensing agreement, or whether I would need to find somebody else to create those icons for me. Now, if I switch over to the context of programming methodology, your textbook highlights object-oriented programming as what is being used on programs today. When I first started programming, we used a programming methodology known as procedural programming, which one of the videos touched on just a little bit. With procedural programming, our goal was to create procedures or functions that we could break up a big program into smaller pieces, and each of these functions or procedures that we wrote had a specific function that it was addressing. Now, with the advent of the C++ programming language and then really taking off in the late 1990s and early 2000s when Java development started coming into play, object-oriented became more of the paradigm that was being used. And it's ideal, as it was pointed out in the text, because you can create libraries of objects that can be reused. When writing the classes used to create objects, you incorporate the data and the functions within the class. The goal is essentially to create a black box that the user of that particular class doesn't have to know anything about the mechanics of the code that were written within the class. So obviously it could be somebody totally different that's using it than wrote the original class. In a lot of cases, there are lots of classes that we can pull into our projects that we can use that are going to be written. We don't necessarily need to know anything about what the details of that class are. We just have a means of knowing what are the methods that are accessible to us, and then the data that is accessible as well. And we can just utilize it, ensuring that whoever wrote the code knows what they were doing. That's the assumption, at least. And we can just utilize it with confidence that it will work. The last actual method, so we have the functional programming paradigm, we have the object-oriented, and we have the procedural methods. Now, functional programming was created in academia, and it treats all functions as deterministic mathematical functions. And I'm sure everybody is probably groaning at this point at the thought of that. It isn't necessarily a popular programming methodology based on the number of projects written in functional programming, but it has influenced other programming languages like C++, Java, C#, etc., to introduce some of the functional style programming elements like lambda expressions that can really simplify code when used correctly. We're going to stop here and we'll take a look at programming languages in the next video.